So, hi everyone. This is the post interview assessment video. So, I had an interview of Node.js with a company for an SD1 role and it was quite interesting. The interviewer actually asked me to ask the concepts, and he also gave me the freedom to check on ChatGPT. So, he allowed me to check the solutions. I mean, answer him by looking at ChatGPT and getting like it was all the questions were conceptual, so he just told me to check and give a response. But it was a very confusing and a messy sort of situation in the interview. So let's discuss it. So yeah, basically the first question was what is Node? What was Node.js? So Node.js, it's a basic question. So let's move ahead. Node.js architecture. So I told him that it's single threaded. Then I told him all of these things which are there in the architecture, which with he was satisfied. And next moved on to the next question. So phases in Node.js include. So this was a new thing to be. What is phases? So let's discuss this. Then this is also like concurrent execution, parallel execution, sequential execution. Then the async execution. For this, I answered how do we basically create functions around using async await and what basically happens when we write an await keyword before a asynchronous call. This is what I told him, but let's also read about this async execution. We might get some more information around this. Then he asked me about worker threads, which I was not aware what worker threads are in Node.js and how they basically work. Other than this, he asked me one conceptual or a one. He gave me one problem basically, in which he told me that there is one one core CPU which is there, and there are a set of tasks which are there. So the first is a synchronous task which takes 2 seconds. Second is a CPU heavy task which takes 1 second. Next is the async task, two which take two, and other one is also an async task. So he told me to calculate the total, how would these tasks perform in order. Like, let's say the program is something written. This is a program, and how will this whole system run, and what will be the time that this would take the execution time of this. So I gave two answers which were I checked afterwards in ChatGPT and they were wrong. So the answer to this was six. So let's check. Let's discuss why this is six. I haven't read the concept behind it as of now. I read it, but it was confusing to me. So I thought let's make a video and elaborate on it itself. Then there was this question which he asked me, and in this, basically what he did was it told me what will be the output. So this was an output question. Then it's the output question is how things will basically work in this. So yeah, let's start. So basically there are one, two, three, four, and I guess one, two, three, four, and just a second. Yeah, so one, two, three, four, five, around five questions in this. Around 5 to 6 questions. Let's start with I guess this question. Let's start with this because this is I think most conceptual question. So as I already googled, so he also asked me question: does promise at all works um, concurrently or parallelly in contexts? So the first question which I want to highlight is this one: concurrent execution, parallel execution, sequential execution. Just, so let's see. Um, so yeah, so the thing that I know and I answered him is parallel execution means we are calling APIs in parallel. Basically, let's say we have to do some API call. Like I gave him an example of an API call and told him that we are, let's say we are calling some asynchronous, we are doing some asynchronous task. So parallel execution would mean that we are doing that asynchronous task parallelly. We're not waiting for one task to complete and then doing the next task. So we are basically doing all the tasks like simultaneously. That, what I told you. Sequential means basically one after the other. So, and I actually didn't told him I didn't actually knew what concurrent versus sequential means. So that's what I answered. So let's read. Sequential execution tasks execute one after the other, which is what I told you. With each task starting one after the previous one finishes. Okay, and so basically character C star fully completes before the next task. No overlap. There is simplest form execution. Okay. Concurrent execution means multiple tasks are initiated and can run overlapping period of time, but they don't necessarily run at the same exact moment. They share the CPU by rapidly switching between them. Okay. So this is a concurrent execution, which so tasks are split into smaller units and are worked on in pieces. So this is often seen in single-thread environment, example Node.js Libuv, where multiple tasks can be initiated at the same time, but the system quickly alternates between them to give the illusion of multitasking. Okay, this is a important thing. Tasks that involve input-output like network request or file operations can be handled concurrently, while the CPU continues to work on other things. Okay, so. Uh, Let's also try to code a bit that would give us a much more better understanding. So, so basically, what it means is what concurrent execution would mean then is multiple tasks are initiated and can run overlapping. So let's say we have a CPU and uh, this is the most important part, I guess. So this is often seen in single thread environment. So like Node.js is a single thread environment, and where the multiple tasks can be initiated at the same time. So multiple tasks initiated, but the system quickly alternates between them to give illusion of multitasking. Okay. So tasks that involve input output, like network calls, can handle concurrently while the CPU continues to work on other things. Okay. Tasks that involve control like network environment and run concurrently, while the CPU continues to work on other things. So async function task 1, async function task 2, input take 2 seconds. Await promise task 1 to both the tasks start concurrently. Okay. Even though both the tasks take 2 seconds, they run concurrently. So the total time is still 2 seconds if they overlap. If they overlap well. Okay. This is a bit confusing, but parallel execution means multiple tasks are executed at the same time using multiple CPU cores threads. So there should be multiple cores, so multiple CPU cores present for parallel execution. And if you have a single core system, then parallel execution is not possible. Okay, this requires multiple execution units. Example, multiple core processors. So this is where I told him that process promised that all would do a parallel execution, and on which he just backfired a lot of questions to me like, uh, how are you saying that Mr. Toll will do parallel execution if we have a single processor system? So I guess I was wrong. So true parallelism occurs when multiple CPU bound tasks run simultaneously on different CPU cores and threads. So true parallelism occurs in, okay. Parallel execution is most useful in CPU intensive processing. Input output bound times like the input output network device don't benefit from parallelism as much since they are most about waiting for response. So let's see the example. Example is using worker threads in Node.js to handle CPU bound tasks in parallel. So okay, CPU bound tasks in parallel. Okay. So work threads, then task in parallel. The promise working input on. Both CPU bound tasks are processed simultaneously on different cores. Okay. If both tasks take 2 seconds and run on separate CPU board, good time is seen to into parallel execution. Okay. This is again needs to be understood. There's a whole concept behind the single difference. I mean, you can learn a lot of things by just reading about these three topics, which is pretty good actually. So there is a lot of data. There is a lot of things to understand actually. So worker threads. Let's read about worker threads. What exactly they do? Create new chat GPT. Let's read about worker threads. Threads in Node.js. What do they basically do? So worker threads in Node.js enable the execution of JavaScript in parallel threads. So basically, this feature allows developers to run CPU-intensive operations without blocking the main event loop, making it suitable for multi-threading tasks in Node.js applications. Okay, okay. So you can set main thread handles input-output operation and non-blocking tasks. Main thread handles all this. Worker threads run JavaScript code in parallel, separate from the main thread, avoiding blocking. Okay, and thread safe. Workers do not share memory with the main thread, ensuring no race conditions. So basically, worker thread in Node.js enables execution of JavaScript in parallel in different thread basically, right? And for CPU intensive operations without blocking the main event loop. So what is event loop used for then? The event loop, why is it written main thread with event loop? Okay. When to use worker threads? So CPU bound tasks, example means processing complex computations is where we should use the worker threads, handling multiple computational tasks concurrently without affecting the main event loop. So if we have to basically handle multiple computations tasks concurrently without affecting the main event loop, tasks that need to be done in parallel for performance gains. Okay. So basically, this is the way of doing it. Key features, whatever the features are. So basically, worker thread, what I'm able to get from this is used for doing CPU intensive operations without blocking the main thread. So basically, it's a thread which uh, do not share the memory with the main thread. So there is a main thread and there is a worker thread. Worker threads handles all the CPU intensive operations, and the main threads does the uh, all the synchronous and the asynchronous tasks which are there. So I have a doubt over here that why is it written like this? What does this mean? So the main thread and event loop in Node.js refer to the core mechanism that handles asynchronous operations. To understand this better, let's break it down. Main thread. So single threaded. So main thread is a single threaded. Node is operated in single thread by default. This means that all the JavaScript code in Node.js program runs in one main execution context. The main thread. The main thread is responsible. Uh, main thread is responsible for executing your JavaScript code and handling the non-blocking input-output operations. So basically, the main thread, like reading files, taking HTTP requests, or querying databases. Okay, and while it can handle many input-output operations concurrently, so while it can handle many input-output concurrently, means it cannot execute multiple pieces of JavaScript code at the same time. This is why CPU-intensive tasks like processing large databases can block the main thread. Okay, making the application unresponsive. Okay, so basically, and what about? So I have another question over here. Are these CPU intensive tasks like, they can be synchronous as well as asynchronous, right? So what is why is a CPU intensive task not categorized as an asynchronous or a synchronous task? I mean, okay, so event loop. Let's read further. Event loop is a crucial part of Node.js that manages asynchronous operations. It allows Node.js to handle many tasks concurrently without blocking the main thread. The event loop ensures that non-blocking tasks like input-output operations. Um, so basically, it manages asynchronous operations. It doesn't block the main thread. The event loop ensures that non-blocking tasks like input-output reading file like will not block the execution of the code. So here how it works. Single thread execution. Node.js runs JavaScript code in a single thread. It processes code synchronously, but when an asynchronous operation is encountered, it delegates the task to other system resources. Okay, this is important. So, what I know till now is basically there is a main thread which is single threaded, and main thread is single threaded, meaning one line it does processing one line after the other, and in between if there is some asynchronous task that comes in, the event loop basically handles it, and this is what is written. It delegates the system to the resource. Asynchronous task delegation. Node.js offloads a task like file read, network request, background to background threads or operating system, allowing the main thread to continue the processing the rest of the code without waiting for those tasks to complete. Okay, callback queue. So this is very clearly written over here, and if we tell all these things in this way very clearly to an interviewer, like so it will be a very good impression to the interviewer as well. So not just off. This is a very good line, good way of writing it. So basically, allowing the main thread to go. So basically, to background threads. So basically, this is important. So it gives to the background threads, allowing the main thread to continue processing the rest of the code. So callback queue, when an asynchronous task complete, its callback is placed in the callback queue. Okay, the function to be executed when the task finishes. Event loop. The event loop continuously checks the callback queue. The main thread is idle between not executing any synchronous JavaScript. Picks up a callback from the queue and execute it on the main thread. Got it. So visualizing the event loop. Imagine the event loop as a loop that does the following. Executes synchronous code. When it encounters an async task, example in input output, it delegates the task. What does delegate mean? Delegation. This is what delegates offloading basically. It delegates the task. The main thread continues executing while the async time is being processed in the background. Once the async task finishes, it callback is placed in the callback queue. The event loop checks the queue and executes callback on by. Okay. So this is an example. So this is start, this is end, this is set timer, right? So basically, what will happen is this will be printed. Then this is an asynchronous task. So uh, console.start and console are executed immediately on the main thread. Set timer function scheduled callback after 2 seconds. But this does not block the main thread. The event loop handles this asynchronously. After 2 seconds, the callback is placed in the event loop callback queue. The callback is placed in the events loop callback queue, and when the uh, main thread is ready, it executes the callback and print timeout callback. Okay. Basically, it prints this basically runs this function. So event loop, it manages asynchronous way of updating them to background threads or the system and execute the callbacks when they're ready. So what are these background threads? This can be an expression. What are the background threads? In Node.js, the background threads refer to the thread that work behind the scenes to handle asynchronous operation, separate from the main thread. These threads are part of these are part of a Libuv library, which is a key component in Node.js instrument for handling asynchronous. Okay, so how background threads work? Node.js is often described as single thread because it runs JavaScript code on a single main thread using event loop. Okay. However, certain operations would actually leverage the thread rule in the background to handle heavy or blocking tasks, such as the file or cryptographic functions. So here's a breakdown of how background threads work. So libut is basically responsive. So let's not get into this types of tasks. This is so okay, configuring thread pool size and all of this. So basically, what happens is let's write some key points, um, which will also be useful for us. So let's try writing some useful points as well. Yeah. So first is main thread. Yeah, main thread. So single threaded. Notice of this. This is important. Oh, this is important. So let's paste it over here. Single thread. Node.js operates on single threaded by default. This means all the JavaScript code in Node.js programs runs in one main thread is responsible for executing JavaScript code handling while the main thread cannot execute multiple pieces of JavaScript at the same time. This is execute random task. Equals and block event loop. So event loop is a crucial part that allows Node to handle many ensures that non-blocking tasks um, not block the main thread. Here how it works. Single thread execution. So this is important. Here how Node event loop works. So here's how event loop works. So let's see. Basically, single thread execution. Node just runs JavaScript to single thread process continuously, but in concrete, delegates the task to other system resources. Now, asynchronous task delegation. Node just offloads a task like file reads background of two other process threads, callback queue, and its callback is pushed again, and the event loop constantly checks. Okay, this is important. Then, what are background threads? So this is a good question, which is also important. Let's also use this. What? Let's start with this. What are background threads? Okay, and the answer to this is again uh, paste this thing here. Where is it? This is what the background threads are. Okay. Now you can read this later again. So I also had one more question. Uh, okay. Okay, then I guess we can move ahead with the other things. Like we understood basically what we were trying to do, since there is a lot of information that we're getting, so we might get distracted from what we were trying to learn and where did we come. So we did started with concurrent execution, parallel execution, sequential execution. We just went into we just connect by connecting ourselves. We moved to Libuv. So yeah. So basically, what we learned is concurrent execution is when uh, tasks are uh, basically done concurrently. By concurrently means uh, the CPU, like let's say there is one CPU, so the task would be like the, done at the same time. Meaning the CPU would be doing it at the same time. So basically, this is how it's in single thread environments where multiple tasks at the same time, but the system quickly alternates. So basically, system is keeping keep alternating between them to give an illusion of multitasking. Okay, this would take 2 seconds. Okay. But confusing. Parallel execution was simple. That we need to have multiple CPUs, multiple cores in the CPU for multiple core CPU to run do parallel execution. So worker threads and node.js handle CPU on. So this is the main difference. Sequential execution, one task, multiple tasks, but not simultaneously. Like alt keep alternating tasks, run the same time on the separate cores and threads. Slow, dependent, more efficient than sequential, fast for CPU on tasks. Parallel execution. Reading the files one after the other, reading two files at the same time, processing the CPU again. Single threaded non-blocking, multi-threaded, multi-cores used. Okay, so yeah, it's pretty okay. So for parallel execution, basically, like what we can deduce is for parallel execution, we have worker threads which uh, for parallel execution and CPU intensive tasks, worker threads are used. So let's ask a question that uh, how what the first is a CPU intensive task synchronous or asynchronous, and how is it handled? Yes. So CPU incentive task in JavaScript and Node.js is typically synchronous by default. This means that while the CPU heavy task is being executed, blocks the event loop. And blocking the event loop means preventing the other tasks like asynchronous or handling of user inputs from being processed until the task completes. Okay, it just blocks the event loop. While CPU intensive tasks are synchronous. So JavaScript, including Node.js, is designed around single thread event loop. CPU, the event loop handles non-blocking asynchronous operations efficiently. Example this. Uh, if a CPU intensive task is run directly in the main thread, it can cause blocking, meaning no other operations would be handled. This can lead to poor performance and responsiveness. For handling CPU intensive tasks, to prevent blocking the event loop, CPU intensive tasks are offloaded so that they do not interfere on the overall performance of the application. There are some approaches to handling the worker threads. Node.js provides worker threads to offload CPU-bound tasks to prevent threads, allowing them to run parallel without blocking the main thread. So we can use the worker thread over here. Worker threads run in the background on separate thread so that the main event would remain free for the handling of the task. This in this setup, CPU intensive work is processed on the worker thread, leaving the main thread responsible. Child process. Another option is to create a child process. Okay, so this is the other different ways. But I was trying to read about worker threads for worker threads too. And I have one more question. Like, does event loop handles synchronous or asynchronous? And what does blocking event loop means? Like, what does event blocking the event loop means? What is exactly is the code software? What is it that is getting blocked? It's a thread. So that's what I'm trying to. Event loop in Node.js primarily handles asynchronous operations, but it also plays a role in managing synchronous code. Though not in the same way, let's break it down. How event loop handles synchronous code? Synchronous code is executed immediately and blocks the event loop until it's finished. Since Node.js is single-threaded and synchronous code runs, no other task can be handled during that time. In fact, if a task takes a long time, it will prevent the CPU-intensive task, including this leads to concept of blocking the event loop. Okay, this means that we're blocking the. Okay, synchronous code immediately and blocks the event loop. So basically, synchronous code is executed immediately and blocks the event loop until it's finished. And if asynchronous code is taking too much time, it will basically block the event loop completely. Okay. So asynchronous operations are executed outside the main thread. So asynchronous code which is there, asynchronous operations are not done on the main thread. This is a very important thing. Allowing the event loop to continue processing the other tasks. These operations register callback or promises which are added to the event loop to be processed, which are added to the event loop to be processed when the task is complete. Okay, non-blocking. Okay. In fact, since asynchronous tasks are non-blocking, the event loop can handle other requests and operations while waiting for async tasks to finish. This Node.js This allows Node.js to implement adding input-output bound tasks and maintain responsiveness. So what does blocking the loop or event loop mean? There's a lot of there's a lot of information. Okay, let's not. I have one more question now. Uh, so synchronous code. So what does this mean? Basically, it's saying that if a synchronous task takes sense, if you prevents the event from handling. Yeah, this was where I had about it. The synchronous tasks are non-blocking. The event loop can handle other requests. So yeah. These operations register callback, which are then at the event loop. What does this mean? Uh, does it mean that a network call is made before the function in which I am calling the network call and just the data that or just the response that comes from the call is executed when this async task gets in from stack. Yeah, this was my problem. Yes, that's correct. You when you make a network call, so basically what I asked was that let's say we are doing a asynchronous task in which we are doing a network call, and if we are doing a network call, so I asked whether this network call would where where that network call would happen. Would it be happening in the callback queue itself, or in the call stack when the thing comes in function in which we are doing the network call comes in the call stack? So this is what I asked. Basically, where are we basically calling it? So let's say there is a code and a part comes in where we are doing a calling the some external APIs which what we are calling. So we know that event loop basically puts up that code and puts it in the callback queue. And when the main thread basically completes, event loop then and the main thread is when the main thread gets idle. Event loop basically picks up the callback queue and puts it in the call stack, and then that particular function executes. But what about that particular network code? So let's say a task which basically main thread, there is a main thread which basically uh, a main thread task is there, and uh, apart from the asynchronous task, the other tasks that are synchronous are taking 2 seconds. So 2 seconds will be taken from the tasks which are there, which are asynchronous, and this asynchronous task is again taking 2 seconds. So the total time that would be taken by all to complete code would be 4 seconds, then, right? But then there is no uh, uh, use of using node in that scenario because still we are wasting that 2 seconds in which the event took that uh, while the main thread was executing it, the event took that asynchronous code and put it in the call stack, and it was that piece of code was just waiting. So that piece of code would have made a network call under the hood. So that is what I am asking. Where is that executed? So yeah, that's the answer. Yes, it's correct. When you make a network call in Node.js or JavaScript, the actual network request is initiated immediately, but the code that handles the response, the callback, then or the promise, is deferred until the asynchronous task completes and the event loop process. So here's the breakdown. So when we make a network request, example an HTTP call to an API, the function that makes the request when the function that makes the request, like the fetch, axios, or whatever we are using, immediately sends the request to the underlying system, like the operating system, network stack, or a worker thread. The request happens asynchronously, meaning it is sent out to the network and your main thread does the code continuously without waiting for response, registering the callback or promise. While the network response is being processed, JavaScript registers a callback or a promise button that will be executed once response arrives. The callback function is placed in the event loop and in the callback queue once the network request is done. Okay, and response execution. When the network response arrive, it could take milliseconds. Response triggers callback function that will register when the process made. The event loop will now process this callback and add it to the call stack revision, but only after the current code execution synchronous code is done. This means the response callback is only handled after the main thread is free. Uh, After the synchronous task has been completed and you will go on processing. Okay, got it. Which is okay. Yeah, so this is a thing which I learned now that okay. So let's move on to the other things. So we basically understood this to some extent, and using this we also understood other questions like how the major question was how is a network or async calls handled, where are they executed. Okay. Okay. Other than that, so let's let's try to answer this question. This is 2 seconds. A CPU intensive task is done on different thread. Async task again takes 2 seconds, and this again task takes 2 seconds. So what will be the execution time? Uh, so if there are two threads which are differently working, the concept behind if a person wants to answer this question in an interview, so if he knows that a CPU intensive heavy task is done on a different thread, not on the main thread, that's done on a worker thread. So this would be done and let's say if two tasks are being executed in two different threads, then these two things would just be completed in 2 seconds, right? After that, this asynchronous task, what would happen is it would be called behind the scenes. The event loop would put it on the uh, like like we studied right now that it will be the network call would be done or the asynchronous whatever asynchronous file or the call or whatever it is, and it will be executed after 2 seconds, right? So okay, so till here it's okay, but what about both of these? So it takes 2 seconds, then it takes 2 seconds. So is it that they are taking 4 seconds, four execution times, or just two? That's what is confusing. What will be the execution time of these two? So we can think of it as, let's say we have a set timeout over here, and we have given 2 milliseconds, 2 seconds, okay? And again a set timeout. So how would it run? How much time it will take? So first it will go in the event to take it to the call stack, then set timeout what to run. Like it will register a callback after 2 seconds, and for this also it will register a callback after 2 seconds, right? So then this thing will be executed, and then this thing will be executed. So let's just know what will be what would be the execution time for these two groups. This code is let's see. Um, let's also fix this. So in this code, there are two set timers functions which are both a delay of 2000 milliseconds, and here is how the execution will happen. Both set time calls are asynchronous, so they're immediately passed to the event loop without blocking the main thread. The JavaScript engine continues executing the rest of the code while both set timers are being traced and sent. After 2000 milliseconds, the first timeout function, timeout one, will be pushed in the event loop and executed. After after another 2000 milliseconds, the second timeout will also be pushed. And result. Both sounds have the same delay 2 seconds, so they'll be fired at the same time or very close to the same time depending on the system. Revolver both set time function will zero after 2 seconds. Execution time. Total time of execution both the time of 2 seconds. Even though there are two set time calls, not blocking. So 2 seconds will be the answer for this. Okay. And what if a CPU intensive task is done before these two set timeouts? If your CPU intensive task uh, is executed before the two set time calls, block the event loop until the task completes during the execution of timeouts. So first block the event loop for 5 seconds. Event loop 5 seconds process every computation task. Okay. Complete after 5 seconds. So total time that it will take is 5 and then 6, 7 seconds, right? 5 seconds, not 2 seconds, because you know total is equal to us. But it will be 5 seconds, not okay. The CPU now run synchronously and blocks the event loop for 5 seconds because it's heavy on continuously operation that doesn't give control back to event loop. The two set times calls are registered immediately, but they their execution is delayed because the event loop is blocked by the CPU intensive task. Even though set timeouts having a 2 second delay, they're not being executed until a CPU intensive. After CPU intensive, the event loop freeze, process the pending task. So at this point, 2 second delay the code because okay, so basically this will take up this will be completed in 5 seconds. Uh, 5 seconds it was. And if this time was 2, then the complete task would be completed in 2 seconds. So if that is the case, then this whole thing should be completed in 4 seconds, right? Wait, 2 second, 2 second, 4 seconds is what? is what I answered and was right. Yes, but I couldn't explain that guy. There was no point. What about this? Let's break down scenario. First is synchronous task, if you want task, and to time is not present. Since the task is it will take block the main thread for 2 seconds. Okay, do not pick up any tasks. Event loop is blocked. The main thread is blocked while the task is executed. No other task is can run during this time. CPU have a task. The CPU have a task also blocks the main thread for 2 seconds. Uh, async task does not block the main thread. It will definitely upload event loop or background threads depending on the nature of the task, such as input output network. This task will take 2 seconds to complete, but since it's asynchronous, the main thread remains. What the fuck? Yeah. This task will take 2 seconds to complete, but since it's a main thread remains free to handle other tasks. Okay. So basically, task 2 is placed in the background. Uh, Here are 2 seconds. Now, what about task 4? Similar to task 2, task 3 also is this will upload the conclusion. Okay. Full scenario. Blocks for 2 seconds. Blocks for 2 seconds. Non-blocking. So whatever this is, what is the total time? For total time, total execution time then 54 seconds, right? 4 seconds for acha. Why the fuck is it saying like this? If it's taking 4 seconds for the synchronous task, the 2 second task should be done behind the scene and they should be completed by them, right? So why again? Why they will take taking 2 seconds more? If it blocks the, let me ask it. If the non-async tasks are once loaded before the sync code blocks the main thread, they must have been completed by the time the blocking sync code finishes execution. So just after 4 seconds, both the async callbacks should run, right? Then why are they taking 2 more seconds? You're absolutely right. If the asynchronous starts, what the fuck? Okay, it has. You're absolutely right. If the asynchronous are scheduled before the synchronous code blocks the main thread, they will indeed start the timer celebration time before the main thread is blocked. Here's how the synchronous work. Scheduled async task first. So task 2 and task 3 are initialized before task 0 task or timers will start immediately. So Execution time is 0 second. Schedule is a non-blocking. 0 to 2 second timer for both task and task start. At 2 second task 0 begins execution. Main thread blocked. But why is it? Oh, I'm getting confused now. 0 second. Schedule this 2 second. Task 2 and task 3 are ready to run, not because the main thread is still busy. 4 seconds. The main thread finishes task 0 but it's still busy with task 1. Why is the processing, why is the task 0 being finished at 4 seconds? Since it started at t equal to 0 and blocks thread uh, main thread for 2 seconds, it should be completed by 2 seconds, equal to 2 seconds. Right. I appreciate your patience. Let's break down. Task schedule, task 2 and 0 to second. Task 0 start executing. The timers are to running, but they are callbacks in 2 second. Task 0 completes. At this point, timers have reached. So, what the fuck? What the fuck? So, what do I do now? It's saying first set 6 seconds, then I ask some questions. Then it's now saying that take it would take just 4 seconds. I'm totally confused. But yeah, it will 4 seconds would be the correct answer for this, I guess. Nevertheless, let's move ahead. We'll discuss it. I'll clarify it again. Some other details. So let's, let's move ahead. Let's do it quickly now. So basically, this is done. It will take 4 seconds, and I know the reason why. And we can also reduce it to 2 seconds by doing this task on a worker thread. If we use a worker thread, then it will do this in 2 seconds. These two will also be were done by them. And this is double done by worker thread. So it will be done in 2 seconds as well. Can be done in 2 seconds as well, I guess. So if we are using a worker thread, okay. Then so this is done. Concurrent. This is done. This is done. Let's highlight this. This is also done. And this is not done. This is done. Okay. Phases. This is also done. This is also done. This thing was also done, I guess. Phases in Node.js event loop. Let's learn about this. Phases in Node.js event loops. Okay, so there is a lot of again information. Uh, why the fuck that guy was asking all this information to me? I mean, for an SD1 having just 1 year of experience, are we really expected to know these things? I'm very sure he might have not been doing all these things while joining that organization, but it's fine. You cannot do anything rather than studying. But these concepts are really interesting to learn. And so, timer phase always scheduled. It checks if any timer are due to be executed in. Not just window opens only will allow him to handle synchronous operation. A timer phase. This phase execute callback schedule. It checks if any timer are due to be executed. Input output callback phase. It executes callback for completed. Mm, This phase is internal and do not often used directly by developers. It's used for preparations for the next phase. Whole phase, the event loop will either execute IO callback or wait. If there no callback, check phase, check execute, schedule, schedule. But what is the importance of this? Like, what is the importance? I don't understand what is the importance of this. Understanding the phase of nodes is really crucial to salvage non-blocking nature, efficient resource management, debugging. I really don't understand all this, but yeah, there are phases in which the event is works in whole phase. The event loop will either execute this or this. Check phase, the phase executes construction of this. Actually, I gave that guy a correct reason in the first go that these asynchronous tasks will be executed at the resolution before this synchronous tasks are done. And I gave the right answer. That guy actually confused me. I mean, he was just wanting me to write this particular answer and give a shitty reason, which I gave. So yeah, like I gave the right answer. 4 seconds if you don't use a worker thread, but we will do it in 2 seconds as well if we use a worker thread, I guess. So yeah, again we are done. Architecture, we have already learned about these things. Phases we just read was a mess. It was a complete mess. Concurrent, this is what this is also we learned. This I already know. I already told you exactly what happens. Worker threads we read about. Then this also we checked how this will run. And this is where we spent a lot of time. How this will basically run. So yeah, our takeaways, most important takeaways from this could be that first thing is all this information, which is a lot. So if we just summarize in 4 or 5 lines of what are our takeaways. So basically, all the asynchronous tasks which is done by Node.js or in the Node.js. So async tasks are handled by event groups. We learned what uh, we learned what blocking the event queue means. We also learned that uh, synchronous uh, tasks could also block main thread if if they are taking a lot of time. Also, they block the event loop, and blocking event loop means even if the uh, I mean, what does blocking the event loop means? That means that no synchronous or async code will be executed during that time. Okay. Then we have the concept of how does the async tasks executed under the hood. So what basically happens in this is uh, while the main thread is running, the async tasks are passed on to the uh, basically what can we say under the hood threads which are under the hood or background threads basically, yeah. So this was the term are passed on to background threads which complete those tasks, and a callback is attached to the event uh, callback queue to be executed for when the main thread is idle or all sync code is completed. This is what also we learned how basically under the hood the asynchronous tasks are already completed by the time they're posted in the callback queue. I mean a callback attached to them is put in the callback queue and then you can loop again, taking those callback functions again and running them on the main thread again. So this is how it is done. We learned about what worker threads are, what worker threads do. Basically used for execution of CPU intensive tasks. These are threads which can be used for not so that the main thread does not get locked while doing an CPU intensive this, what we got? Yeah, this was an important question. Execution time, how things would run around this. Okay, so this is also important. Assuming one core CPU, the execution time for this piece. Right, so just do this. What the hell? Okay, so other than this, what did we learn? I don't think we tried learning phases of event, but we couldn't actually do it. So yeah, that's pretty much about it. We learned these summaries this of our today's understanding and learning that we did around Node.js. So that's pretty much about it. I'll be doing more such videos and pasting it on my channel, and we can learn and like understand the core and the basic like core concepts of how things basically run for Node.js. Yeah, so thank you. Bye.